Hey everybody, welcome. Great to have you today. My name's Adam Penna. I'm here usually to continue the conversation in 3D printing and additive manufacturing, but I'm very excited to have the guests I have today. I have both Anthony Graves coming to me from HP, and he's the head of software over there, and Harshil Goel is the CEO of Dyndrite, and he's also the founder. So, gentlemen, welcome. Glad to have you here today.
Thanks for having us.
Yeah. So I know, we're talking a little bit before we get started, and all the manufacturing is constantly looking for process optimization. It's really the big overarching umbrella there of what we're trying to do in manufacturing is optimize everything as we're going along. Now, inside of all that, there's so much, background that has to happen with, feeling secure, security, and also education that has to go into, educating the people out there that are doing these things so they could accept them and all the normal processes and practices. So looking at that, I know, Dyndrite has been working to support that overall effort by harnessing and distributing maximum power. That's kind of like the power to scale scenario that you've been talking about. And I was part of, I actually sat in the Dyndrite Day 2020, and I got to see a lot of what was happening. And of course, the news has been out with the partnership between HP and Dyndrite, and it's been exciting to see and then see that application actually come to fruition. But there's so much more that's going on. So I wanted to talk a little bit more about what's going on in the industry and what do you think the industry needs right now?
Harshil, do you want to start us off?
I can lead us off. I think the industry as a whole probably just needs to take a step back and really look at the forest for the trees, right? I mean, we've been here now for over 30 years. We had some goals. Some of them were met, some of them weren't, and need to really take a real hard look at what we need to do to kind of get over those roadblocks and bumps. I'd say I'm obviously very biased, right? Looking at this industry a few years ago, to me, the key glaring issue was a software issue. I think I get to take credit for coining the term, the manufacturing hardware surpassed the software. Like, all these machines are fantastic. They can do all kinds of honestly insane things at actually an insane scale. But, from my perspective, the software is the thing that was really holding everything back. And trying to figure out ways to help people see around that, discover new things, is kind of where I think I think what the industry needs.
Yeah, sounds good. Anthony, how do you feel about that?
Yeah, no, I agree 100% with what Harshil just said. And I think you can really break it down into two categories. It's definitely software. That's why I'm at HP. My background was in subtractive traditional manufacturing, fabrication, injection molding, and all that for years before I got into additive with the startup. But one of the things that I think has been frustrating to a lot of people in the industry is they've kept hearing about this promise of additive, right? And that the promise, I think a lot of people would define is not just the processes and the capabilities of the machines, like Harshil pointed out, because as he noted rightly, the machines are able to do things today that are just absolutely amazing. And the software, for the most part, to drive the capabilities of those machines is lagging. But there's really two categories, and what drew me to HP was one of the two categories, and that was developing the software that's unlocking the new business models and the real potential around additive, and maybe we can come back to that. The other half is what Harshil's championed, and that is, I don't want to, I'm saying component in the very most, what's the term, generous way, because the reality is that the underlying technologies that drive innovation have to be developed. The technology that most of the industry was relying on was developed 20 years ago. And here comes Harshil out of Berkeley, could have done anything, his background, if you look it up, aerospace, different things like that. And he decides that he's going to create a technology that is going to help manufacturing and additive manufacturing initially and specifically. And so this, to me, the Dyndrite kernel technology was really the key to unlock the ability for companies like HP to develop these new innovative solutions to deliver the promise of additive, to help deliver the promise of additive, which hasn't happened up to this point.
Yeah, that's for sure. I know there's a lot going on that's pushing it towards that direction, but it's important. It's important with the partnerships that are happening for people to be open and talking about these things.
Yeah.
So seeing Harshil and you working together and seeing the whole industry open up with the development council that you've been putting together, it's exciting because there's a lot to be opened up. There's a lot to be talked about, but there is also that bottom line of intellectual property, you know, and that's really where you kind of, you know, hit the wall in a lot of senses, but I've seen that kind of come, you know, opening up better as people start talking about what they can be doing together. So I know now, you know, how does Dyndrite, you know, approach that, the nervous system and IP? How does all that kind of come together when you're actually developing and working together?
I think the first step of all of that was realizing and acknowledging that there are these walls and fences, right? And that they exist, right? And some of them exist for very, very good reasons, and some of them exist for reasons that many people forgot. And the idea was to say, you know, it's not like my way or the highway. It's to say, look, we want to work with everyone, right? Let's reevaluate what IP truly means in this space, and let's work together to protect you, right? And I think that's hopefully, you know, a mature approach here, right? The second aspect of this is, and I think, you know, I think Martin Stoyer mentioned this during our DDC panel a little bit earlier in the year, right?
Martin
We as
Stoyer
industry,
from EOS, yeah, awesome.
Yeah, we have to help each other, right? We can't be fighting each other. Like, we have to help each other as an industry, right? And there are ways to do that without necessarily trampling over each other's IP, whether it be job ticket formats, slicing formats, geometric formats, standards, right? These are things that we can all do together that help each other across the board. Because, I mean, quite frankly, someone who wants to buy a polymer machine is not going to accidentally buy a metal machine. Someone who's buying a multi-million-dollar metal machine is not going to make an error in which machine they decided to buy. Right? Like, you know, they're going to buy the one that meets their needs, their build requirements, and their material specifications, right? So I think the key step here was to be mature and hit this IP issue head on with everyone involved, and just be transparent and open as possible, at least from our side.
Yeah, that makes sense.
Yeah, I was just going to say one of the things from an IP standpoint, and it's one of the, I don't want to say it's one of the pillars, because we sort of have these 4 pillars that support our UBM, our Universal Build Manager powered by Dyndrite application. But off to the side is an architecture that we created around a capability that Harshil and his team had the foresight to build into their kernel architecture, and that was this plugin architecture. Because one of the biggest challenges and the limiting factors today, having 3D printer OEM companies, manufacturers work together in order to facilitate some type of streamlined integrated solution for manufacturing around additive, because you have that today in subtractive for the most part, is the fact that in order for you to get the most out of a machine, there is special IP, you know, that everybody calls it their secret sauce.
Yeah.
And the fact of the matter is that secret sauce is integral to the operation of the machine. It's how tool pathing works on some types of processes and some types of machines. It's how the thermals work in other types of machines. Companies are not going to hand that over to an independent third-party software developer, let alone hand, like, for example, you know, we were talking with a number of companies that we were, you know, happy to, when we announced the Universal Build Manager, to announce with, and that was SLM, Renishaw, Econity, a whole host of the major names, Aon and Possible Objects, etc. When we talked to them and we let them know what we were doing, the very first thing, within the first 15 minutes, I explained our approach. And our approach was that we were going to have an architecture that would allow them to provide the IP to us in a way where it was zero risk. They weren't exposing it. It was sort of packetized, if you will, in the form of a plugin or an add-in. And as soon as we said that, the reaction was overwhelmingly positive. Not just positive, but overwhelmingly positive, because they all saw that as a big limiting factor. And consequently, every OEM, for the most part, has had to create their own software so that they could protect the IP, but still give customers a tool to be able to actually use the machine. So Dyndrite provided that necessary opportunity, I think, to bridge that gap, and it's one that we're taking advantage of.
Makes sense. Now I know everything that's happening outside of that. Now that the partnerships are together, you've been able to come up with this universal build manager, and that's one of the first tools that kind of accentuates what's going on. And I had a chance to see that, and people could check that out a little more if they want to check out Dyndrite Day. You go into a full demo of what's happening there. But I had just some questions. I guess for the layman, for someone like me to understand. I really understood that you're looking at objects, and then you're relating some sort of intelligence to, like, say, a voxel or something like that. So it's a different way of actually telling the voxel what power needs to go to it because of a certain sort of application or certain sort of process you're performing. So somewhere in there, there's that understanding of, okay, now you have the math that actually powers that, say, voxel, and it's different than the math that would go in if it was just erroneous math that had to be run on the machine. Am I understanding that right? Is that where the speed's happening? I'm trying to really understand the speed and the power behind it.
So I think there's just two sides to this, right?
Yeah.
The first side is on the time and speed side,
Yeah.
right? So when data is read into our engine, right, it's essentially considered the master data, effectively God's data, if you will, and you don't touch that data, right? Like, that data is, sacrosanct, right? And the idea is, how do you process a number crunch on that data as effectively and efficiently as possible, whether it be on a CPU or an NVIDIA GPU, or quite honestly, using them both together to blow the fans out on your computer, right? So that's one side, right? The second side of this is taking all of that existing geometric data and adding another layer of, what you just essentially said, metadata intelligence, right? So, for example, in the demo, we showed colored surfaces, using that colored information from the surface CAD data to drive an automated process. If you're talking about the voxels, that's getting more into the tool pathing side. Maybe you want to apply different types of chemicals and things on a voxel or pixel by pixel basis to enhance the quality of the print. It could even be in a non-voxel format, like, let's just say on vector toolpaths. You want to now change laser speeds and feeds also. So I think you're definitely on the right track, but I think it's a little bit more broader and abstract than that, in that you want to apply that same type of logic and philosophy to everything that you do, because when you have that extra data, now you can use it to do something intelligent with it from a manufacturing, design, or otherwise perspective.
Yeah, and that happens on the design side and also the production side is what I'm seeing. And Anthony, maybe you could speak with that on the production side, what you've seen as it harnessing that power and actually being valuable.
Well, it's interesting, because the way that we look at the technology may be a little bit different than most people would. Okay, and I'll provide a little bit of context here, because as I had mentioned, Harshil and his team had an event right after we made our announcement. I was able to talk a little bit more about our application, and I described it because a lot of people were curious, how does Universal Build Manager, there are other build prep tools out there.
Sure.
Where do you guys fit in? And I said, we did not set out to create a category killer, like a category killer for like build prep, even though there are going to be some amazing capabilities. And you got to see, I call it a teaser demo that Harshil did with our software. There's so many cool things that we're doing, that there are applications or customers that have applications that have some of the existing applications, other tools, and they're going to say, wow, this is going to be a huge benefit for me over here. So I don't want to discount any of that. But I said, as rather than a category killer, we look at our tool as a new category creator. And I mentioned this earlier about these new business models. The business models that we are driven to support were born out of the fact that when HP developed their 3D print technology, like some other 3D print technologies that are out there that are geared towards production, you start to look at the business models that rely on production and not just high volume. If you're going to do 1 million parts, I don't know you're going to do it with additive unless it's a part you physically can't construct using any other technology, any other process, right? So the areas that we're looking at are enabling on-demand manufacturing for real,
Mm.
in additive, leveraging the benefits of additive, and then customization and personalization. That's it. And that's when I had originally spoken to HP before I joined them, they were finding some of these same barriers. And they're like, there aren't tools out there. Customers want to buy our printers. This is HP's printers at the time. And they said, but the software doesn't exist to drive the business behind those. So when we look at our software, the HP Universal Build Manager, first of all, it's a build manager. It's more than build prep. It takes more of the process development and product development aspects of the process into the equation. But also, we're driving things like automation. And so in order to do that, you have to have a very performant, streamlined, efficient, fast engine. And that's what the kernel provides to us. And then we take that and we build all of the other tools on top of it. So speed is critical. The ability, the fact that it's like a hybrid voxel based kernel, hybrid kernel. They're able to do GPU acceleration for certain processes versus GPU acceleration or CPU acceleration. And so the key for me is that not only does it unlock the ability to deal with the data and the designs at a much more granular level and add value by adding metadata to it, but also it's the speed, the performance that you get by attacking the problem from that vantage point. You're able to harness all of this compute power that exists today, whether it be on the GPU or the CPUs.
And Adam, let me give you like a very specific example, right?
Please,
right,
yeah.
with colors, right? So I'll give you a couple toy examples. Let's say for some reason we're going to print a bunch of polymer rings, like engagement rings, right? And we're going to print a bunch of gears, right?
Okay.
But, and when I say a bunch, I don't mean like 10, I mean like 1 million. in one
fully
build.
nested bed, yeah.
Personalized.
Yeah, personalized.
Right?
There you go.
And each of them is slightly different.
Right.
Not just from a serial number perspective, but they are actually all slightly different due to something
designed differently, or
right?
Yeah.
Right.
Sizes and things like that.
And moreover, right, like let's say on a ring, there are certain areas of the ring that you want to have certain type of aesthetic qualities, right? So you want the software to know, hey, these areas are really important. Make these the highest quality possible. And on the gear, these areas are really important from a surface on surface interaction standpoint. Prioritize these things, right? Now, what's the old way to do that? The old way to do that is to manually bring in a part one at a time.
See how it goes.
Hit the nest button and wait a few days.
Yeah.
Right. And go around selecting triangles on your STL or 3MF nonsense.
Yeah.
And try to tell the software, hey, these are important. Versus now it's point it on a directory, use the colors to tell me automatically where it is, right? And this way the designer has more input in the manufacturing process, right? Because the color is a mechanism of communication, right? It's an interface,
yeah.
right? And then let's have the scale and power to do all of this on like 1 million parts as fast as humanly possible. And as Anthony said, kind of in an on-demand basis, maybe even on a factory floor. Maybe these parts are even coming in quickly, and you don't even know how many you have to print on a given day, right? Yeah. That's the level of scale personalization we're talking about, right? We're not talking about printing 20 gears on a plate and waiting 4 days to for someone to put that together. Does that make any sense?
No, that does make a lot of sense. I'm glad you explained it that way because, looking at what's actually attributed to the kernel and what can be built, obviously, this is just one great example with the Universal Build Manager, but there's a lot of other things that are going to start to actually be produced from this. And so it's exciting to know a lot of what that interface is. I know even in the demo, you were looking kind of showing at the PostScript of AM, which was more of the Python side and getting into how you could just slightly change some things that are already set up from an automated process, right? You're automating the process at that point. So when you go back and maybe slightly change things, you don't have to reinvent the wheel per se. You just go in, update a few things inside of the script, and it runs your process for you. So that's really interesting.
It's the automation, but I think the other side of it is actually the codification of that process. Right? It's one thing to automate it. It's another thing to codify it, make it a recipe, and now have a binder that you can use forevermore.
Right.
Right. It's now actually capturing and keeping that intelligence around, as opposed to every single time you start a build, you start from square one.
Right. No,
You
that's
see that?
huge. And then also that, so now what I'm thinking too is the OEMs, the contract manufacturers, the people out there that are using the equipment can build their library of what is fitting to them inside of their own personal circumstances.
Yeah, this is where I want to draw a distinction, because I think this is very important. Anyone that is using any existing tools is going to say my tool can do that, because most of the tools support some level of automation.
Sure.
But it's not just it's not automation for the sake of automation. This is more than templates. Okay, so let me describe what I mean. Now, you could just use it to create templates. Okay, fine. But having those static templates is one thing, but being able to update them dynamically on the fly unlocks the true potential. That's the key. And so,
awesome.
I mean, and nobody, this is one of the things where, and I was surprised, so Ryan Palmer, I report to Ryan. He is our SVP over the software group. I manage product and strategy for him. But it was one of the things that when I was talking with him before I joined HP, I'm like, wow. I mean, I was surprised that, honestly, that people had been thinking about it, because most people don't. It's like they think about automation for the sake of templates. They don't think about the way you can really unlock the true power, because in order to drive the scalable production, especially around on-demand and customized, personalized workflows, you have to have that dynamic ability to as Harshil said, be able to codify those best practices, but then have the flexibility and agility to tweak them as needed on a part-by-part basis. Going back to what he said on the color, here's a perfect example. You can codify, I'm going to recognize that blue is a keep-off surface, or an area of a part. Whereas red, that's where I want, or I should have probably used red. Red is the keep-off, and blue or green, I want you to put the supports here, right? Or green is where I want the cosmetic surface orientation to be. That is a way to preserve the design intent to manufacturing. Everybody talks about, well, design intent. Well, how do you do that? Well, it's through that tool. So it's one level is the fact that through the kernel, we're able to assign values to colors, which is really cool. Through the BREPs, not working in some generic neutral format, but on a BREP, a SolidWorks file, or another popular CAD format. It's that then when I get 25 different parts, or 250 different parts, or 2,500 different parts, where those colors are all located on different parts of the part, different areas of the part, that's where you can start to see the power of this advanced level of automation, I would say, right? It's not just templates. If people are thinking templates, they're missing sort of our point of developing the software. We're not doing it just to do what other people have done. We're doing it to really unlock the scalability that the industry has been complaining about. When is it gonna blow up? When is it gonna become like a first-class citizen in manufacturing? And that, going back to also what Harshil said earlier, and Martin Stoyer at EOS, this is what he said. He's like, look, we all have to work together to elevate additive to its rightful place. And so the UBM, the Universal Build Manager, it was our intent in developing this application to have it play an important role in unlocking that potential. And then, of course, the Dyndrite kernel is like a key enabler, making that possible from a technological standpoint, a foundational standpoint.
Adam, so, I'll flip the podcast. I'll ask you a question.
Right? Yeah, here we go.
If you have a warehouse of laser powder bed fusion machines, do all the machines print the same?
No, heck no. Yeah.
Right. So,
yeah.
And that's because we have really sophisticated machines that, change based off the humidity in the air, right? It's not bad. It's just the state of affairs of the complexity we were at. And so, Anthony just talked about having something that's dynamic, right? Like, going back to, Python and PostScript, having something that's dynamic and adjustable to the part, but you actually also need something that's very dynamic and adjustable to the machine for the very reason you just said.
Ah, there you go.
Right?
Yeah. No.
Right. And so when
Yeah.
you go and make a build, when you like, let's say you go slice the whole thing, right? Right before you send it to the machine, you might actually want to change the tool pathing on a per machine basis.
Sure.
Right?
Yeah.
Maybe the machines in Singapore in the summer are very different than the machines in North Dakota in the winter. Right? You need that level of control. And again, it's not that this is necessarily specific to additive, right? Things contract and expand when things heat and cool.
Right.
When you're
So
dealing
many
with
different
these
parameters,
tolerances, you just need that extra level of sophistication, right? And that's where this whole PostScript for AM thing comes in. Rather than storing the hardcore data that you fix, right?
Right.
For the batch of machines, you store the data, you store the recipe for the data, and right before you go to the machine, you say, okay, which machine is this? Which country is it in? What's the temperature outside? Make all the little tweaks and adjustments, and then
let me
go.
give you, let me jump in. And
awesome.
this is funny because Harshil's like, so I gave an example of parts. He gave an example of machines. So I'm going to come back to the parts.
Yeah.
Where
awesome. From
part to part, you may have to adjust the margins between parts or the packing density in different, like he said, it could be the tool pathing. Like on CNC machines, you have different tolerances. You have your really high tolerance, tight tolerance machines, and then your older, looser tolerance machines. That, the scale when it comes to additive and the sizes that we're talking about, when we're talking about putting drops of additives or we're putting a laser on a point, you better, the fine tunability that working at the level that the Dyndrite kernel allows us to target, and not just us, it's the other OEMs, because as I said before, they may say, hey Anthony, this is great, we're glad you're using that kernel and you could do all this stuff, but we're not going to tell you what the magic code is to unlock the potential. So a lot of that IP can be leveraged by the OEMs off the machine in order to get better outcomes, part mechanical, cosmetic capabilities, performance, etc. But there's also some really cool, unique things about the HPUBM that, if more people adopt the kernel, will unlock more power, more performance, and impact scalability as well. And I don't know if Harshil wants to chat about any of those things. But
I was going to say there's one really simple example.
Awesome.
How long does it take to send the slice exposure data from your computer to your favorite OEM machine?
This is my favorite example, by the way.
Yeah. Okay.
So I'm glad he brought it up.
Like no one wants to talk about this.
We haven't talked about it before. We have not. We've talked about it on the phone, but we've never talked about it broadly to the industry yet. But this is a good one.
Yeah.
Right. I mean, like if you're looking at, let's say, for example, like an HP machine, right? Just because Anthony's in the call, what's the resolution of the machine and how much stuff can you put in there? Are we talking about megabytes, gigabytes, terabytes? I mean, we're talking about terabytes. And the funny thing about this is we're going even towards petabytes, right? I mean, look at also how often, look at how often the machine build volume is doubling or tripling, or the number of lasers is doubling or tripling, right? Even, we're recording this right after SLM did their announcement, right? I mean,
the 12 laser machine
that build volume is, right? Or even, for example, AMC, right? Which is an EOS company, right? Like, look how massive those build volumes are getting, or even Velo 3D, right? Rather than necessarily storing all of that data and kind of, walking it over to the machine or slowly streaming it, doesn't it make more sense to just send the recipe to the machine and compute the data as you need it when you need it? You don't have to hold 4 terabytes. Moreover, when you slice something at 50 microns, do you go through all the slices one by one to see which one had an error in it? I know some poor souls do that side by side,
Right.
doing
Oh,
one at a time, trying to find which line is the wrong line. I
very
mean,
manual process. Yeah.
that's insane.
Yeah.
Right? There has to be tools to fix this data transmission issue, right? And there has to be tools to help fix this data correction and data error issue as well, right? And that's again, it's coming back to the heart of what does the industry need? It's a fundamentally
Yeah.
more mature way of thinking about this data problem.
Yeah, this is well, and honestly, I mean, I know we don't have all day. I wish we did to talk about this, but I will tell
No,
you,
it's all good.
Harshil. I mean, this is he did not overstate. I think he maybe understated the ramifications of this in the real world. So your background, Adam, maybe is maybe a little bit closer to mine in the manufacturing world. We've been around longer. You know, Harshil's a young guy, and I'm an older guy. But here's the thing: the real world implications of something like this. When it takes you a day, 24 hours to send a file into a machine. Now, some machines, maybe you can do that in the background, okay? Right. In other machines, you cannot do that in the background. And even if you are, what is the potential for there to be an issue during file transfer? Just being able to shrink the file sizes down.
Almost every time. Yeah.
Yeah, I know. So here, yeah. I know, because and that's the joke. Everybody's network is bulletproof except for the one you're on at the moment, right? It's like everyone else's is bulletproof. Yeah. So the thing that's interesting though is that, so a lot of times when we talk about performance, it's about how quickly can we nest or pattern or slice or add supports and stuff, but it's also how quickly can you get a file onto a machine. I cannot repeat the words that have been used by customers when they have to wait 2 days to get a file transferred to a machine, or a day. It's insane. Right. And so one of the cool things that when we were thinking about developing this automation solution, communication is obviously part of that, you know, feeding the system, feeding the factory, we call it. We were trying to think about how can we address this problem, and then all of a sudden Harshil's like, oh, by the way, you know, you can do this with the kernel. And I'm like, oh my God. So we literally, as Harshil, if you saw the demo, he went through and he built out a build. And then he said, hey, look, here's the Python code. And he sort of walked through, here's all the different sections of the code. So you can see where all of these different tasks were being performed, right? And you could go in and modify a part of that. That recipe, as Harshil likes to call it, that program, that file is very light, and it's like just over a K or something like that. It's super, super lightweight. So instead of having a terabyte file, if I had like maybe 90 gigs of data files and a 2K recipe file, immediately, you know, you've cut the file down 10%, you know, or by 90%. Right. And so that's interesting. But of course, you know, in that way, you know, the way I've described it before is we're sort of like a, I guess I could say this, like a PDF writer, and the kernel on the machine, any of these machines could be the PDF reader. So we write it, and then all of a sudden, like post-processing in the CAM world. Yep. But when we post it in a very efficient format, and then that could be exploded on the machine. We're not there yet. Nobody's doing it yet. No. But I don't know, whoever the first one is that decides to do it is going to have a huge advantage. Now, of course, Harshil mentioned the large work envelopes that you have, build envelopes on some of the newer machines. I mean, there's some that over 1 meter, it's just like, oh my God. And then, of course, you add 12 lasers like SLM, and this file size, you can imagine just within the next 2 to 3 years, it's going to grow exponentially. And there are real world, somebody has to manage that data. The data has to be stored somewhere. Mm-hmm. And if you're not allowed to connect to the cloud, all that has to be stored on-prem, right? And so people don't think about basic things like, oh my God, we have to have enough storage to store all of these files to run these
Right.
machines.
Yeah.
So that's a real world sort of benefit that is just out there. It's not out of reach. It exists today. It's just going to take the industry to come together and say, hey, that makes sense, and let's do this, right? Let's implement this.
By the way, this is not a new or profound concept, right?
No.
I'll ask you another question. Do you remember the dot matrix printer?
Of course, yes, I
right?
do.
And how we went from the dot matrix printer to the laser writer.
Yeah.
Do you remember the story of that or how that came to be?
Not offhand.
So a very smart person named Steve Jobs went to another very smart person named John Warnock, who was a mathematician, and they together, realized, okay, PostScript needs to be created to enable these machines, right? So what is PostScript? PostScript is simply an interpretive language for taking 3D geometry and fonts and converting it to a machine input for 2D printing, right? That's literally what it is, right? And PostScript became basically one of these ubiquitous standards across the globe, right, for all of these 2D printing devices.
Yeah.
So then the case is still, again, why doesn't that exist for 3D, right? Like why isn't there a ubiquitous, maybe even open way of going from an arbitrary 3D data set to a machine controlled data set that can be posted to the machine?
Wow.
Right.
Yeah.
And even in that sense, I mean, the funny part about this is Adobe's the person who invented PostScript, and in Anthony's example, which is spot on, they also invented PDF, which is an extension of PostScript.
Yeah.
Right.
And it's not that necessarily even that like the profound benefit of it was the on-the-demand compute, right? That's the key, right? And quite honestly, if in the 2D world it led to the desktop printing revolution, well, I'm genuinely curious as to what's going to happen in the 3D world.
Yeah, there's so much going on. It's hard to tell right now. It's a wonderful wave to be riding. I'm glad you guys are here explaining this today. There's so much to be, to look forward to, obviously. And it's partnerships like you have right now with HP and Dyndrite making this happen that are very exciting to say the least. Now, I know you talked about what's happening now. Now the things going on in the future. You talked a little bit about what can be happening in the future with the kernel and with working together in these open partnerships. I did mention something during the Dyndrite Day, and I know you guys answered it too. But it's a close, concern of a lot of people, obviously, even laser powered bed fusion and all the other, all the other different tools out there you could use. But so what is the possibility with the kernel actually helping something like a closed loop monitoring system? I think, there's where everybody's looking for more power to compute those things and to actually look at what's happening with the data. I know that you said that that's kind of far out on the horizon, but what do you see that kind of makes that closer? And is that something that Dyndrite could possibly tackle in the future?
So I'd say the only reason I say that's far out on the horizon is not necessarily from a technological perspective. It's just from the number of legal people that have to be involved from every company involved.
It's huge, right? That's why I bring it up, because it's like,
Adam,
yeah.
I've signed some pretty funny 4-way, 5-way NDAs.
Sure, yeah.
You need the sensor people, the simulation people, us, maybe even the end user to do a final ROI project, and the printer. Right? And I mean, we're doing our best because we're just going to come in and say, okay, I'll just sign whatever the hell you have. Because I'm sure everyone is sufficiently protected, right? I don't need to add my own interpretation of where the comma needs to go. I think the beauty of it though is, like that's why we made a major effort to get as many walks of life on our Dyndrite Developer Council, right? I mean, we're actively talking, of course, to Altair and Ansys, right? And we also recently announced Link 3D.
Yep.
The thought was for all of these, what I would call hybrid, value propositions, like institute process monitoring and control being one of them.
Yep.
We had to create an environment to get all the people in the same room, right?
Yeah.
Because, for example, if you have the kernel running on the machine with some, simulation software product dynamically updating and changing what's going on the machine, you also need to figure out a way to report it to your MES system so that you can part qualify it, right? This is not like a 1 or 2 step issue. This is like a it's like a whole pipeline issue.
Yeah.
Right. And so
Yeah.
I'm hopeful. I think there are a lot of hungry people in the space.
Yes,
And
there are.
honestly, the only real impediment here is legal.
Yeah. No, it's the bottom line, but
Yeah.
obviously the more you communicate and bring it up. Anthony, do you have anything to add about that?
Yeah, no, yeah, that's Harshil certainly did not understate the challenges around that. It's, when we reached out to almost all of the OEMs that were out there, big and small, and we talked about some of the challenges that they were facing, and from a software perspective, and from a data perspective, and from a process control perspective, and man, it's daunting. All the technologies exist, like Harshil said today, and the desire to do it is there, but the IP, it always comes back to IP. And the reality is that whether anybody likes it or not, unless a company standardizes on one technology, and they may be able to do that and plan out production maybe for a decade, but long term, there's going to be very few companies that are going to standardize around one technology for all sorts of reasons, right? Somebody else is going to come along with something 8 years from now that's, so the issue becomes, do companies go towards more closed loop systems, where they're or closed systems, not closed loop, closed systems where they're doing everything, and then they're making customers or potential customers choose, do I want integration? Do I want to be able to get the best of all worlds through using different technologies from different companies? Or are you going to force me to do this? And if you do, you're going to have to replicate a lot of what these other folks are doing, whether it's simulation, whether it's QMS related, SPC, things like that for quality control, inspection, metrology. It is interesting. It's one level of complexity up from a legal standpoint and an interaction standpoint, like Harshil's saying, from standardizing around like something like PostScript, right, or the PostScript for additives. So, it would be great. But I will say this: I think enough of the smart, thoughtful OEMs have been struggling with this long enough, and their customers have, that I think I've seen a willingness for discussion. And I think that's a big change. 5 years ago, that wouldn't happen. Today, it is happening. So that's good. Yeah.
That's a good sign for sure. I know. Hey guys, it's been wonderful having you here today. Is there anything else that you'd like to talk about while we have you here?
Harshil,
that's the question that catches me off guard. Watch out over the next 1 year. A lot of really fun stuff is going to happen. I can't talk about it, but I mean, I'm ever the optimist, and I mean, to put it simply, I want to take things and just flip the table, right? I want to change, and I want to push people to think in different ways. And I think over the next 6 months to 12 months, I think we're going to start to see, a slightly different kind of mood to the conversation, if you will, right? I'm hoping it's going to evolve from what we've seen over the last, 2 years to decade. And I'm excited, right? I think additive might actually just turn the corner now. And I'm doing everything in my, blood, sweat, and tears and power to make that happen.
Yeah,
amen to that. Anthony, anything to add at this point?
Yeah, I would just say, I try not to say this often, so Harshil's head doesn't get big, but Harshil got Forbes one of the 30 under 30.
Nice. Congrats on that.
Award,
That's awesome.
some prestigious award from Forbes, and I had commented at the time. I think it was before. It was before we actually developed our partnership, that I was thankful that Harshil chose to focus his superpowers in mathematics and things on manufacturing, because quite honestly, until HP reached out to me, I had honestly given up on additive ever achieving, or at least within the next 10, 20 years, achieving its real potential. And people say, well, what do you mean? Are you the only person that, could solve these? No, it wasn't even that. If it had been that, I would have just,
Yeah.
It takes more than a person. It takes even more than HP. But first of all, the fact that HP, who is a relative newcomer to additive in 3D printing, listened to their customers, number one. And maybe, you're always, when you're young and you're a startup, even though it's funny to call HP a startup in something as big as they are, and they've been around forever, right? I mean, they're the godfathers of Silicon Valley. But really they were. And so using that approach and listening to the customers, they were able to identify, man, it's almost, I was talking to somebody that was around in the early days of that and saying, oh my God, it was scary because it's like, what do we get into? The printer is just part of the challenge, right?
Yeah.
And so when I joined HP, because I'm like, we want to solve these challenges. We want to solve the challenges nobody else is looking at, right? And that's good because there are other solutions out there that do a great job for the business models that exist today. And HP is like, that isn't what we're interested in. We're interested in doing different things, new things. Then you have this technology, like Harshil talks about, that has implications beyond the machine, beyond software and in additive, but other industries as well. It's exciting. I think here's this opportunity. That's what got me back in the business and having to do expense reports and stuff. It was like, we have a chance to fix this. Yeah. And you don't get that many chances to fix it. And that's awesome. I think all of the stars are lining up, from the OEMs and the other software companies, Ansys and Altair and Hexagon and the simulation space, and everybody coming together and talking. I have high hopes. So.
No, that's good. I like that. It was like a Godfather reference. You're trying to get out, and they pulled you back in. Yeah. No, but no, that's awesome. I mean, I guess to paraphrase a couple of awesome things I've heard on this conversation is a lot of great things going on. But one thing that hit me really hard is something Anthony said, and I'm paraphrasing here. He said, "But you're saying the future is personalized and on demand." Yeah, and that's something that I keep seeing as a reality, and I'm glad that that's the focus you're looking at going into the future. And then for Harshil, this is a huge paraphrase, but you said this in another, I think it was Dyndrite Day. You said, we are the glue connecting the digital thread of tomorrow. Yeah. And that's a beautiful thing. So thanks for this work that you're doing together. And I can't wait to see what's going to be happening now with Dyndrite and HP. So thanks a lot for being here, guys. Appreciate it.
Man, thank you.
All right.